The heat is finally breaking. After days of triple-digit temperatures, cracked pavement, and overwhelmed power grids, the air is about to feel cooler for the first time in over a week. Most people will breathe a sigh of relief the moment that first breeze rolls in. But meteorologists are watching this exact moment with a very different reaction. Weather science, the collapse of a major heat wave is not the end of the danger. In many cases, it is the beginning of an entirely new and far more violent one. Stay with me. Because what typically happens in the 48 hours right after a heat wave breaks has caught entire cities off guard. And this time, scientists are saying the setup is more dangerous than usual. To understand why, you first need to understand what a heat dome actually is. A heat dome forms when a massive area of high pressure parks itself over a region and effectively traps a bubble of hot air. Underneath it, like a lid on a pot. Air sinks inside that dome, compresses, and warms even further as it falls, which is why heat domes can push temperatures well past what the season would normally produce. This lid also blocks clouds and storms from forming, which is why heat waves under a heat dome are often bone dry, day after day of relentless sun with no rain in sight. But that dryness is deceptive, because while the surface bakes under clear skies, the atmosphere above is quietly loading up with moisture and energy that has nowhere to go. That stored energy is the key to everything that happens next. Meteorologists describe it using a measurement called CAPE, which stands for Convective Available Potential Energy. Think of CAPE as fuel sitting in a tank. During a prolonged heat wave, that fuel tank fills up day after day because the hot, humid air near the surface keeps instability. As long as the dome holds strong, nothing happens. The fuel just keeps accumulating. But heat domes do not last forever. Eventually, the high-pressure system weakens, shrinks, or gets nudged aside by an approaching cooler air mass. And that is the moment everything changes. When a heat dome finally starts to break down, it does not do so quietly. T. The boundary between the retreating hot air and the incoming cooler air becomes a battle zone, and this is where all of that accumulated CAPE gets released, often within just a few hours. Meteorologists have described this exact process playing out recently across the central and eastern United States, where a week-long stretch of extreme heat gave way to powerful thunderstorms with frequent lightning, damaging wind gusts, and rounds of torrential rain. In one recent case, a location just northwest of Des Moines, Iowa, received more than 9 inches of rain within a single 24-hour window, while suburbs west of Chicago picked up 4 inches. Forecasters explicitly warned that the atmosphere was loaded with moisture that would get, in their words, wrung out as the heat dome collapsed and cooler air arrived from the north. This is not a rare or isolated pattern either. It has shown up again and again this year on both sides of the Atlantic. In parts of Europe, a heat wave that pushed temperatures past 40 degrees Celsius eventually gave way to storms that knocked down hundreds of trees, cut power to homes, and triggered emergency calls by the hundreds in a single region. Emergency responders in Romania reported similar chaos after an intense heat spell broke, with widespread vehicle damage and nearly 1,000 trees brought down by the resulting storms. And in the northeastern United States, a heat dome that pushed one major airport to a scorching 104 degrees eventually broke apart into flash flood warnings across New York, Philadelphia, and New Jersey, with heavy rain stranding cars on flooded highways and even causing part of a store roof to collapse under the weight of rushing water. If you're new here, this channel breaks down the biggest weather and climate stories unfolding around the world, so make sure to like this video and subscribe so you catch the next update before it happens. So why are scientists more worried than usual about this particular pattern this year? The answer comes down to the background conditions this heat is forming on top of. This year's heat waves are not developing in an average climate. They are developing during one of the warmest years ever measured, layered on top of a rapidly strengthening El Niño pattern in the Pacific. Researchers have pointed out that El Niño itself is nothing new, but every time it returns, it now operates against a much hotter global baseline than it did in previous decades. That means the atmosphere carries more moisture into every heat wave. More energy accumulates before the dome finally breaks, and the resulting storms have more raw fuel to work with when that energy is finally released. Climate attribution researchers studying this year's heat events have found something striking when they compared today's temperatures against historical records. Extreme heat levels that would have been considered virtually impossible to occur back in the 1970s are now being reached regularly. And nighttime, temperatures during recent heat waves were found to be over 100 times more likely today than they were just a couple of decades ago. Warmer nights matter enormously here because they prevent both the human body and the atmosphere from ever fully cooling down before the next day's heat begins building again, which means even more energy stacks up before the eventual collapse. This is also why health officials are treating the transition period itself, not just the heat, as a genuine danger zone. A heat wave in Europe earlier this year was linked to well over 1,000 excess deaths in France alone once a full accounting was done, and health organizations have gone as far as warning that extreme heat events now need to be planned for with the same seriousness as a seasonal flu outbreak, because of how consistently they are now recurring year after year. When that kind of prolonged heat stress on the body is immediately followed by violent, fast-moving storms capable of flash flooding, downed power lines, and even isolated tornadoes, the compounding risks to already vulnerable communities multiplies rather than simply adding up. The flash flooding piece deserves special attention because it is often the most underestimated part of this entire pattern. People understand heat. They know to drink water, find shade, and stay indoors during the worst of it. But very few people psychologically prepare for a flash flood arriving within hours of relief finally showing up. Emergency officials have repeatedly had to warn residents in these situations not to drive through flooded roads, since water levels can be rising faster than they appear, and pavement beneath the surface may already be washed away entirely. In several recent events, rainfall totals reaching 6 inches fell within just a handful of hours, turning ordinary streets into fast-moving water within a very short window of time. Often while people are still recovering from days of heat exhaustion and letting their guard down, there is also a wind and lightning danger that tends to get overshadowed by the flooding headlines. As the heat dome's boundary collapses, the same instability that produces torrential rain can also generate damaging straight-line winds, frequent lightning strikes, large hail, and in the more extreme cases, brief tornadoes. Meteorologists monitoring this. Year's transition events have specifically flagged the combination of high instability, strong wind shear, and a lifting boundary as the exact recipe capable of turning ordinary thunderstorms into rotating, dangerous ones. Downed trees and power lines during these transition storms have already caused widespread outages and property damage across multiple regions this year, on top of the flooding itself. So here's the pattern to watch for, wherever you are. If your region has been sitting under a prolonged stretch of unusually intense dry heat, especially heat that has felt trapped and relentless for several days in a row, do not assume the arrival of cooler, cloudier weather means the danger is past. That shift is frequently the exact signal that a large release of stored atmospheric energy is about to occur. Forecasters increasingly describe this transition period as carrying its own distinct warning category, separate from the heat advisory that came before it, precisely because the risks involved, flash flooding, severe wind and lightning, are different enough to catch people who only prepared for the heat completely off guard. Scientists studying the bigger picture behind all of this keep returning to the same underlying concern. These are not freak, one-time coincidences. They are becoming the expected, repeatable outcome of heat waves forming inside an atmosphere that is holding more energy than it used to, year after year. Attribution studies published this year describe the deficit between incoming sunlight and outgoing heat radiation, essentially a direct measurement of how much extra energy the planet is retaining, as having doubled in recent years compared to historical norms. That extra energy does not vanish. It shows up somewhere, whether as a longer, more intense heat wave, or as the violent storm system that erupts the moment that heat wave finally breaks. There is a longer-term consequence to this pattern that rarely gets attention once the storm coverage fades from the news cycle. Repeated cycles of extreme heat, followed by violent flash flooding, place enormous strain on infrastructure that was never designed for either extreme, let alone both back-to-back within the same week. Roads, sewer systems, and power grids built decades ago were engineered around a much narrower range of weather conditions. Baking heat causes pavement to expand and buckle, while the sudden arrival of several inches of rain within a few hours can overwhelm drainage systems that were sized for gentler, more spread-out rainfall patterns. When these two extremes hit in rapid succession, the damage compounds in ways that a single isolated event would never cause on its own, and city planners in several regions are now openly discussing how outdated their infrastructure assumptions have become. Agriculture faces a similar squeeze from this same boom and bust pattern. Crops that have spent days baking under an unrelenting heat dome, already stressed and thirsty, can then be hit with a sudden deluge capable of causing flooding, soil erosion, and waterlogged root systems within a matter of hours. Farmers describe this whiplash as one of the hardest conditions to plan around because neither irrigation strategies built for drought nor drainage systems built for steady rainfall are well suited to a pattern that swings this hard and this fast between the two extremes. Some agricultural regions affected by this year's heat and storm cycles have already reported crop damage from both ends of the pattern within the same growing season. Power grids deserve their own mention here as well, because they tend to get hit from both directions during this transition. During the heat wave itself, grids strain under record electricity demand as air conditioning use spikes across entire regions simultaneously, sometimes pushing utilities to the brink of rolling blackouts. Then, just as that demand might finally start easing with cooler air arriving, The same storms responsible for that relief bring damaging winds and lightning capable of knocking down power lines and transformers outright. Utility crews in the several affected regions this year have described responding to outages caused by the storm collapse phase before crews had even finished addressing heat-related strain from the days before, leaving very little recovery time in between the two separate stresses. There is also a psychological dimension worth mentioning, because human behavior during this transition period tends to work against basic safety instincts. After enduring a week or more of relentless heat, most people are simply relieved the moment temperatures start dropping and clouds roll in. That relief often translates into lowered guard, more outdoor activity, and a general assumption that the worst has passed. Emergency officials have specifically pointed to this psychological shift as part of why flash flood warnings issued immediately after a heatwave breaks tend to be underestimated by the public compared to warnings issued during more obviously stormy weather, even though the flooding risk in these transition events can be just as severe, and sometimes arrives with far less advance warning than a typical storm system moving through. Before you go, if stories like this one matter to you, hit subscribe so you do not miss the next breakdown the moment new weather data comes in, because this pattern is showing up in more places, more often, and understanding it could genuinely help you stay safe the next time the heat around you finally starts to break. Thank you for watching, and I will see you in the next one.